Good afternoon, everyone. We are Bruce and Wei from Netflix. Today, we are talking about how to innovate live streaming with a client simulator. This is how we innovate in Netflix. So we start with an idea. We build it into product. Then we run experiment with our users. At the end of the day, we look at the data. We evaluate all the normal QE matrices. Then we make a decision whether we want to productize it or we continue iterating it until we see improvement. However, we meet unique challenges with live with this approach. So Netflix started offering live from early 2023. So we are still in the middle of building up our portfolios. We have our weekly programs such as Dinner Time Live, or you're more than welcome to watch our incoming big shows. The boxing game between Paul vs. Tyson on November 15, and two NFL games on this Christmas Day. The challenge we are facing is we have many more ideas than the number of live events we have. So if we need to wait for each live event to verify our ideas, then the line of the testing will be longer than today's launch line. And also, it's not the best idea in the world that I break NFL by running one of my little experiments during Christmas. Now let me hand over to Bruce. He will explain how we bridge the gap with the simulator.
So we're doing a bunch of things to deal with this, and one of them is we're developing a client simulator. So the idea here is we take all of the things that make sort of a video session, like the video encode, the network behavior, like the throughput or the response time, and then what kind of device the video is running on. We feed this into the simulator, and then the simulator runs the production client code base using all of this information. So it sort of mocks out all of the interactions that the client has with the rest of the world. And as output, the simulator spits out all of the client behavior. So like the different bit rates that the client chose, whether or not the client rebuffered, the way the buffer evolved over time. The goal here is if we pass in some production session, sort of all of the logging information we have about a production session, we should be able to get exactly the same output from the simulator as we saw in the original session. So this is kind of hard, this is a lot of work, and we're not quite there. But we invested a lot, so the behavior is pretty close. And the more time and the closer we can get it, the more useful this is. So this lets us run experiments. And the sort of obvious experiment we could run here is we could write a change to our client, write some JavaScript, pass it into the client, and see what happens to the client behavior. But there's a lot more sort of experiments we can run. We can actually run experiments with any of the inputs to the simulator. So as some examples, we could run experiments with video encodes. We could try out increasing the highest bitrate of a video. Or what if we remove different rungs from the bitrate ladder? What would happen to rebuffers? What would happen to the client buffer? We can test out changes to the network. So for instance, we could run using throughput from a different region where we haven't even had a live event yet. Or on a very congested network, if we have, hypothetically some upcoming event that we think will have a lot of traffic. And then finally, we could run with different information about devices. So we could, for instance, imagine what would happen if the device would have a larger buffer or different configuration. And one of the cool things about this is a lot of these things are things we could never even run experiments with in production. Like we couldn't go to people's houses and solder more memory onto their TVs. But with this simulator, we can sort of imagine what would happen to QoE, and we can use this to inform our business interactions with the TV partners. So this is roughly how we work with a simulator. We come up with some idea, we implement it in the code base, then we run a bunch of simulations. We can do this pretty quickly, and so we can have a pretty tight loop of analyzing or iterating. When we finally have something that we think might actually work, then we can go and we can run an A/B test. And this lets us run A/B tests on only the most very promising ideas, which helps us deal with these sort of fewer live events that we're having. And then finally, once we have something that works well, we can either productize it or we can go back to the beginning and try again. So the big win here is that we can work a lot faster. One of the reasons for this is that the simulator itself is very fast. So if we wanted to run an hour-long video session, because we're mocking out all of the interactions between the client and the actual device, we don't need to run it for an hour. We can run it in just a few seconds. We can also run many sessions in parallel, and so we're running about 10,000 sessions in 20 minutes, and this gives us immediately a good idea of whether or not something works at scale. The simulator is also deterministic. We're not using randomness in the simulator, and so if just one of these 10,000 sessions doesn't work, we can download it, we can run it locally, we can step through it in a debugger, we can send it to our colleagues who maybe know exactly what the problem is and they can help us fix it. And this lets us debug things very quickly. And then finally, the simulator is safe. We're not actually running experiments on actual users. And so we can run things that we would never feel comfortable with running experiments with, like what's the most amount of rebuffers we could have, or what's the least amount of rebuffers we have. And once we have an idea of what that range is, we can start seeing where our algorithm fits and where we can get improvements. Now I'm going to hand it back over to Wei, who's going to talk about a case study.
Yeah, thanks, Bruce. He just showed that there are lots of possibilities with the simulator. So now let me just present you one of the most recent examples with this. So how we evaluate low latency dash with the simulator. So this is a very quick overview for low latency dash for those who are not familiar with it. So in this diagram, we have the horizontal line, which is time, and then two vertical lines, which is start of the encoder and the time when the user joins the live event. On the top part, we show how dash works. In the dash, the encoder will output a segment, 1 second at a time. As a rule of thumb, a client normally will buffer 3 segments to start playback. That will give you roughly 6 seconds of client buffer, assuming a 2-second segments. On the bottom, it shows how low latency dash works. So in low latency dash, it divides a segment into multiple smaller parts. Normally, it's referred as CMF chunk. In this example, we divide 1 segment into 4 chunks. Each chunk will be 500 milliseconds, assuming a 2-second segment. The client can start playback by just buffering 3 CMF chunks. So the client buffer will be 1.5 seconds, which is significantly lower than the dash case, which has 6-second buffer. Unfortunately, we cannot verify this idea in Netflix yet. The reason is our encoding vendor does not have this capability to generate CMF chunks. Instead of waiting for them to get ready, so we go ahead and modify our simulator to mimic the low latency dash streaming behavior. What we have done is we changed the client behavior from consuming 1 segment at a time to 1 chunk at a time. Then we can verify the low latency dash performance using our simulator. Now let's see the results. So in this graph, we show the relationship between the latency and the playback buffer size. To the right, we are reducing the playback buffer size. It's not very interesting to see that when we reduce playback buffer size, the latency goes down. But we do observe that comparing to dash, low latency dash can reduce the latency slightly when we set the buffer size to be the same amount. In this graph, we show the relationship between the rebuffers and the playback buffer size. So again, to the right, we are lowering the playback buffer size. Without surprise, the lower the buffer is, the higher the rebuffer risk is. But what's interesting here is we observe that where we are increasing the rebuffer, the speed of rebuffer increase in the low latency dash is much slower than the dash. So for example, in these 2 operation points, we can achieve much lower rebuffer compared to dash. We are achieving a lower latency. So this gives us valuable insight without actually implementing low latency dash in Netflix ecosystem. Yeah, one more thing I want to point out is it's very cool that we can generate the result of all 18 different treatments with 1 iteration. If we need to use live event, we need to wait for multiple live events to generate all the results. In summary, so we show that simulator is a very useful tool to speed up innovation, and we can use it to test changes for all the components in the ecosystem, which include the client-side, encoding, networks, and devices. If you want to learn more, come to talk to us after our talk. Thank you.